Good morning. So this is Dr. Looney. This is for my AP Calculus class, AB. And today we're going to be continuing the topic of integration. But this time we're going to introduce what we call U substitution. So generally when you are doing U substitution, you're going to be looking at composite functions. And I think a easy way to kind of remember that is possibly U substitution if you see where you need to multiply, or if it has division in it, or you'll see cases where you have sine and exponential functions. So, you know, those may be possible cases where you need U substitution, but that's not always the case. But if you look at this first example, the first example that we're going to be looking at, we're going to start out just pretty basic. We're going to be looking at first degree polynomials. So as you can see, this is not where you can just write this as the sum or difference of two functions. Now, if this was x to the second power, then you could write that as the sum. You can actually write x to the fourth plus 8 as the sums and differences, but it'll just get too convoluted. It'll just be a lot of unnecessary work. So it's not going to be efficient to rewrite this function as a sum and difference of functions. So the best solution for this is to use U substitution. So you do realize this is multiplication because this is just x plus 4 multiplied to itself 8 times. So that's what I was saying in the beginning. Generally, if you have the multiplication of functions, then you're going to use U substitution. But again, that's not always the case. So let's look at this example. Now, you want to get when you're doing U substitution, you want to be able to get it to something you can integrate. So in this case, we're going to try to get this function to look like U to the n, because if I could get it to look like U to the n, then I can just do my little rule, right? I add 1 to my exponent, divide by the new exponent, then add c. So more than likely, your U is always going to be what's inside the parentheses. So in this case, well, what's inside the parentheses? X plus 4. So I know my U is going to be x plus 4. So now I need to find what my du is going to be because I'm doing a U substitution. So I need to put my function in terms of U, which this function is in terms of x. So I need to get it in terms of U. And I need to get my dx, I need to rewrite my dx as du. So that's what I'm trying to do. So I need to find my du. So I'm going to take the derivative of u with respect to x. So since I'm taking the derivative of u with respect to x, well, the derivative of x with respect to x is just 1. And the derivative of a constant is going to be what? It's just going to be 0. So my du over my dx is going to be equal to 1. But keep in mind, I want to find a replacement for dx. So I need to get dx by itself. So you can see that if I just multiply both sides by dx, I get du is equal to dx. So now I have my substitution. Everywhere I see x plus 4, I'm going to put a u. And everywhere I see a dx, I'm going to put a du. So that means my new integration is just going to be u to the 8th du. And based off my integration rules, what do I do to my exponents? I just add 1 to them, divide by the new exponent, then add a c. So that's going to give me u to the 9th power divided by 9 plus c. Now the last thing that we need to do here is go back in and plug in the value of u. And we know u is equal to x to the 4th, right? X plus 4. So I find an answer. I'm going to write it over here to the left. It's actually going to be x plus 4 to the 9th power over 9 plus c. So that is the final answer here. So as you can see again, this is only when we're talking about a first degree polynomial where our leading coefficient is going to be equal to 1. And so that it works in this case. Now, if you look at the next example here, this is also a first degree polynomial where the leading coefficient is 1. So I want you to pause the video and see if you can complete that example. I will be walking around to answer any questions that you have. Okay, so if you have completed this successfully, you would know that your u is equal to x minus 10. Your du over dx was equal to 1. And so your du was equal to dx again. So now everywhere I see an x minus 10, I can put u. That's why we're doing a u substitution. And everywhere I see a dx, I'm going to put what? Du. So I get the integration of u to the 4th du. Now this is something that I can integrate. So I'm going to do what to my exponent? Again, add 1. Divide by the new exponent, then add my c, and I'm done. Well, I'm not done because I got to go back in and substitute in for u, and that's going to be x minus 10 to the 5th power over 5 plus c, and so we're done. So this is probably the simplest case that we're going to be able to integrate using u substitution. But now let's look at a different case where our leading coefficient is, we still have a first degree polynomial, but the leading coefficient is not going to be equal to 1. So in this case, we can see that our leading coefficient is going to be equal to 2. And so, and we also have this, this constant out here. And with a constant, you can always factor it out. So if it is a constant, I suggest that you go ahead and factor it out. This is not the only way you can do this, but this is the way that I recommend. So I'm going to go ahead and factor out my 4. So that gives me 2x plus 6 raised to the 6th power dx. Now again, my u should always, well not always, is usually going to be what's inside the parentheses. So u is going to be equal to 2x plus 6. But this time when I take the derivative, I'm going to get du over dx is equal to 2, and it's not equal to 1. So this is where it's going to get a little different, but it's not that much difficult. So don't worry too much. And again, so this implies that my du is going to be equal to 2 dx. And you're going to see, you're eventually going to do enough of these where you're going to just write your du and go ahead and write your dx on the other side. So this is du is equal to dx. But remember, we need to find a substitution for dx. So we need dx to be by itself. So I need to solve for dx. So that means that I'm going to have to divide both sides by 2. So that means that 1/2 du is equal to dx. So I know what my dx is now equal to. It's equal to 1/2 du. And I know what my 2x plus 6 is equal to. That's equal to u. So now I can just do my direct substitution. Now I still have this 4 out here, so don't forget that. I got 4. This is going to be u to the 6th power. But everywhere I see a dx, I now need to write 1/2 du. So now that I have my 1/2 du, now what can I always do with my constants? I can go ahead and factor them out. So this is going to be 4 times 1/2. Now I'm going to integrate u to the 6th du. And my laws of integration says what? Well, if I want to take the antiderivative, I just increase the exponent by 1. So this is going to be u to the 7th over 7 plus c. But remember, I have this 4 times 1/2, which is on the outside. So I need to make sure that I bring that over because that's going to be times. Well, 4 divided by 2 is just 2. So this is going to be 2 u to the 7 over 7 plus c. You do not have to multiply the 2 to the c because 2 times a constant is still another constant. So you do not have to multiply that. Now we just have to go back in and substitute in the value of u. And so, well, not the value, but the expression for u. So that's going to be 2. And u was equal to 2x plus 6. So that's going to be 2 times 2x plus 6 to the 7th power all over 7 plus c. And we're done. Now I have an example now that you can pause and try. So I want you guys to try this example right here. Okay, so this is the solution. So you can pause the video and look through the solution to look at the steps that I did do to complete this problem. And again, you can stop me at any time. I'll be walking around to ask those questions. So here you're going to do another pause, look at the solution, and see what you come up with. So now let's look at polynomial functions that are greater than 1 degree. So this is a 2nd degree polynomial. Now again, our u is going to be what's inside the parentheses. And so our u is going to be x squared plus 11. Now you can see that this is 3 times x. 3 is a constant, so I'm going to go ahead and factor out the 3. So I'm going to have, let's just write this over to the side, 3 times the integration of x times x squared plus 11 to the 3rd power dx. And so that means that my du is going to be this time 2x, and then I need 2x, and then again, like I said, eventually you'll just be able to just know to write the dx next to that. So that's my du. But I do not need, this time you see that I need a x and a dx. So I need to have a substitution for x dx. Because once I plug in my u, I'm going to have this x dx left. So I need to find a substitution for now x dx. In the past, we only had to find a substitution for just dx, but I need to replace everything in terms of u. So now I need a substitution for x dx. What do you see here if I just divide both sides by 2? So I know that 1/2 du is going to be equal to x dx. So everywhere I see a x dx, I can put a 1/2 du. So let's go ahead and substitute that in. I got 3 is still on the outside. And so my u is going to be, my x squared plus 11 is going to be u. So this is u to the 3rd. Then I'm going to get 1/2 du because that replaces my x dx. But I need to take my 1/2 out. So that's going to give me 3 over 2 integration u to the 3rd du. So that integration is going to be 3 over 2 times u to the 4th over 4 plus c. And if we multiply, we're going to get 3u to the 4th over 8 plus c. And so now what do we need to do? We just need to substitute in our u. So that's going to give us 3 times x squared plus 11 to the 4th power over 8 plus c. So that is our solution. Of course, I know I went pretty fast, so you may want to pause and go back through that. Again, I'll be here to answer questions. And once you do pause and go back through it, I want you to look at this example right here and see if you can complete that example. This will complete what we'll do in class today, and hopefully it's been a help. And again, I'll be walking around. Hopefully it's been helpful, and I'll be walking around to answer any questions that you may have over u substitution. Thank you, guys, for your patience.